Digger Dev. So let's look at a little bit more of the technical background behind the whole EEG system, and understanding what is there will enable us to think in other terms and what else might be possible. So we go back to the screen view, and basically at the moment there are 5 applications that I've been building over the last half year with the help of AI. And AI here is fully integrated in a software development environment now. And it's basically a matter of asking here something that we want to change, and it will, because I'm not a programmer. All of these programs I've built purely with AI. It's called vibe coding. Where you don't know how to code, but the AI does it for you, and you just kind of keep tweaking it and asking it to make changes and testing it until it works. So I call this ecosystem the ACE, which stands for Alpha Coherence EEG, and there is the ACE recorder, which records the EEG from the device. Then after the recorder, it goes into the database, and let's take a look at the database. In the database, the original recording gets separated to ensure privacy for the subject, so that their name and their date of birth and their email address and all of that is completely separate from the data to meet the standards for that kind of data of the US and the EU. And so now all of the subjects, instead of having their name, they're called subject 1 and 2 and 3, etc. So let's take a look at, for example, subject, let's say 15. Subject 15 has 2 sessions, and in session number 2, all of their data, so every session has the same structure, and the original EEG data is just this one file. And if we look at that one file, we will see that, I have to load a montage. There we have the data. And here it starts to get good. And we can see like one of the channels is a little noisy. Other than that, everything is fine. We can see their heart rate here as well. Their heart rate variability can be derived from this signal. And we can see a nice little alpha burst over here. And here there's something happening on top, and so this little section here I've selected manually and marked it, and that's why it has this color, and that gets left out of the EEG data. And as we scroll forward in time, here's another little eye blink that he has there, so that part gets removed and this part gets removed. But in between we have all this good data. And we have their eyes open period, and then we have their eyes closed period. You can see here the list here. He's got quite a bit of noise, so actually all of this part gets removed. But here we have all this clean alpha waves. 2 positions are noisy, but those we don't consider in the circle anyway. And then there's their TM period. Right now they don't have alpha, but I'm sure it will come back. And then we have their rest period. This is the end of their TM. So here's again beautiful alpha waves that continue in their 2 minutes rest. So anyway, so this is the raw data, which first needs to get organized, where we say which section is eyes open, which is eyes closed, which is TM, etc. We can give different tasks. And we have to manually mark when they're blinking their eyes and when they're creating distortions on the signal. That takes a few minutes, let's say 5 minutes for a whole recording, but it needs to happen, and we do it manually. After that, the file arrives in this database, and again it is separated from all of your private data. And then after it's there and in a structured database by subject and by session and all of that, it sits in the database, and all these additional files are not there yet. For that, we go into another program called ACE Analysis. And in ACE Analysis, that ACE Analysis goes into the database. So here we have ACE analysis, and it reads the database and it sees any new files, and then it processes the newly found files in the database, and it can run the coherence analysis or the spec param analysis, which is a different measure, very important actually for our purpose. It can generate a PDF report out of that. It can generate an MP4, like a video of the circle that moves, and now it shows the statistics on that, and all of that will be on the screen. And now it gets interesting. It can generate the coherence time series to H5. H5 is a type of file format that is very suitable for saving big time series data. So here we can have the coherence time series to H5, and we're going to see that in more detail in a moment, and also the spec param to H5. So this basically weasels through the whole database and processes any new files. And then now we're back in the database. We see subject 15, session 2, and here their task is I open, and we see all these files here. You can see they're labeled H5, and this is the alpha band coherence H5, and there's the time series of that. And we're going to take a look at this file here. This is for the eyes open task, and I call this the per hertz coherence time series. So what does that mean? Let's take a look. All right, so this is what we get when we open that file. And first there is a table that shows us the artifact mask. What does that mean? Earlier I showed in the EEG data, we could see here all of the periods where we mask a period as being noisy. Oh, I gotta remove this. So these periods of noise, we can see that. And so this little section of time here gets masked, and it goes per second. So here we have a mask, and here this whole list actually, everywhere where it says artif, that turns here, this artifact mask, and it takes 1 second per, basically if we have 10 minutes, we get 600 seconds, and then for every second it says whether it is masked with artifact or not. So the first second is fine, the second there is a artifact, then again, etc. So that data is here. Then we have the channel pairs, and this will tell us that the first thing to appear is channel O2 and P8, and O2 and T8, and O2 and F8, etc. We have 19 channels, 19 positions that we measure on the head, and that gives us 171 different combinations of coherence. So this one with this one, and this one with this one, and this one with this one. That's 171 possibilities of coherence, and they all get recorded and they all get saved in this file, in this time series H5 file. And so if we look at this chart over here, this is kind of the big one. Down here we have 171, and so this corresponds, so the rows correspond to all of the possible, all of the coherence pair combinations. So this position, and this position, and this, all of those combinations, 171. And in this direction, you will see we have 40 columns. And what does that mean? That corresponds to the whole frequency range that we're looking at, from 1 to 40 hertz. And for every hertz, for 1 hertz and for 2 hertz and for 3 hertz, etc., we are saving the coherence. So not just only for the alpha range, but just for every individual frequency. So if we go to the top of this chart here, earlier we saw that the first position was, I think there was O2, which is over here, and I think P8, which is over here. So the coherence between those two positions is stored over here, and first it is on 1 hertz, and then 2 hertz, and then 3 hertz, and then 4 hertz. But it goes further. So we have a tremendous amount of information here. But it goes further. You can see this counter over here. It goes from 0 to 599, so in total 600 pages. And as I flick through this, you can see every time it changes. For every second of data, we have saved the coherence for every coherence pair on every frequency. So this is a tremendous amount of data. And of course, we're not going to stare at these numbers in this chart. That would be silly. However, so I'm going to close this again. That is exactly what our other program does. So we have the data, it is sitting there in the database, and it is sitting there for every individual frequency. It sits there also pre-calculated just for alpha and for beta and for gamma. So we don't have to average those ranges. And we have the time series, but we also have the value over the whole, the average over the whole time span. And now, how does this get relevant? These are the files. So if I open my ACE view and I start it, I'll take a moment, and in the background you will see we're going to have this over here is the back end, and it's almost started up. Oh, yeah, there it is. And now the back end is running, and over here this is the front end, and that means that now we can go to the browser and we can load all of that data, and this is what I've shown in the other video. And so basically when I open the study, this program in the back end and in the front end, it loads all of those little H5 files, and then we can skip through it and see what is happening there. And when we go to the report view, then it does a similar thing, but on an individualized basis. And we can, so we've seen this, but there's some more features here that I haven't shown in the other video. If we click the settings button here, then we can change, you know, if we want to see alpha, beta, gamma, or we want to see a custom range. We want to see, you know, maybe this person specifically has a peak at 9 Hertz. So we're going to go to 9 Hertz and, you know, really specify that. And instead of seeing the normal channels that we have in the circle, we also want to see some additional channels, which I usually switch off. So let's, now it's generating, and this is what it looks like. Oh, it's just still adding a few extra channels. This is what their coherence looks like when we added the additional channels, and we're only on 9 Hertz right now. Or perhaps we want to see them at 32 Hertz for whatever reason. You know, it turns out he's got something going on at 32 Hertz. And so it's generating, it's pulling all of the data from that big sheet that I showed earlier. And so, of course, the coherence is not that high in this range. However, we're actually only showing coherence above 0.7, above 70%. And I can change that here as well. So now if I lower the threshold of what we show to 0.3, to 30%, then as it's generating, oh, we got to generate plot. And it's generating right now. Then we can see their coherence with those settings. Oh, it is still loading the charts below, and the charts below have another feature that I haven't shown yet, which is very interesting actually. And there's also this chart, which I will talk about in a moment. There we go. Now we have the chart, what it looks like when we have the 30% coherence and up with all of the channels. So all of a sudden we see a lot more lines that were hidden earlier because we set the threshold at 70%. And we set the gradient also starting from 70 to 100%. So now we have these charts here, and of course they're lower because that's the nature of it. And I can change that here to, instead of 40% to 100%, 0 to 100% on the Y scale. So I've changed the scaling here. if for whatever reason I only want to see this part of the range here, then I can actually change the slider here. And as I'm moving the slider, you will see that these numbers slightly vary. They don't vary that much because, well, this guy is pretty steady. And most people are very steady, actually. But so we can really zoom into a single little part of their recording. And then there's the spectral parameters chart, and it shows us now the x-axis is not time, so this is not time domain, this is what is called frequency domain. And in frequency domain, instead of having time on the x-axis, we have the frequency range, and this applies over the whole recording of 10 minutes. And we can see that they had a big peak at 9 hertz specifically, not at 10 hertz or at 8 hertz or 7 hertz. They peak at 9 hertz. Other people, they might peak at 10 hertz or whatever it is. And we can see here that there was no, once you've seen a few of these charts, then you know what sort of the curve is. So we don't see any specific bumps sticking out, but sometimes there might be a big bump over here, indicating still a lot of thoughts going on in the beta range or in the gamma range. Or if we see a bigger bump over here, and we kind of see a bump over here at 5 hertz, then that indicates some sleepiness. So this chart with a little bit of practice can actually tell us a lot of what is happening in the person while they are sitting there. And again, here we can change the some of the settings of the charts. And similarly in the study tab, let's select eyes open. I already showed that we can go to beta and gamma, but we can also change the channel selection here if we want that. And we can see right now by default I show the executive coherence, but we can also enable to show in the chart only the average coherence, or both, or only the executive coherence. And we can change here which age range we want to see. So that's another thing where we can really play with the data quite a bit. And all of this requires all of the data that we have stored already in the database. Now the thing is, and this is where things get interesting in my opinion. At the moment, the analysis program that I showed earlier saves all of the data in the H5, and right now it does coherence and it does the spectral parameters. But it can do so much more. It would be some amount of work to add more modalities to it, and there are so many more interesting things that can be done other than coherence. So with a reasonable amount of additional development, more can be added. And then in this viewing program, we can visualize it all in whichever way we want. So this is all open source. It has a high credibility because the sources that we used are developed at Ivy League universities in open source collaboration with each other and made available for free to the public. So those are the algorithms that we use. And that means that we have that level of credibility when we use these sources. And there are so many more things than coherence that we can do and that I'm very keen on further developing. And that would enable further research. Another one of the things I'll be working on pretty soon is making, and well, honestly will not be that much work, the circle that we have right now, it applies to a single person. However, we can make it for 2 people or 3 people or 4 people and see the interconnectedness, the coherence of interbrain coherence basically, where imagine where in the circle half of each of the circle are different brains, so this is one subject, this is the other subject, or 1/4 of the circle, each quarter will be one subject. And then we can have it over time in the same way that we have the video, and we can see them pulsating and peaking in coherence every now and then. There are so many things possible, and it really is a matter of putting our minds to it and making it work. And right now with AI, it has become so easy. I mean, it's still a lot of work, but it's possible. And it's not expensive. Like we don't have to hire programmers for half a year. It's completely within reach. So that is kind of what I wanted to convey as the possibilities within what is now possible in this program. So I'm open to any suggestions pretty much from anyone. Thank you so much. Take care, Dev.